Hello folks, today we're going to look at a special type of sequence. Now, this special type of sequence is called an arithmetic sequence. So our node today is to find the next term in a sequence and the nth term of an arithmetic sequence. And of course, our do, you can see, is going to be, we're going to be able to do problems much like what you see in the do right there. Now, let's take a few minutes and let's just review a few terms. Okay, so first of all, our first definition is a sequence. Now, remember, a sequence is a set of numbers in a specific order. An example of one would be this. Now, I want you to go ahead and put this in your Cornell notes as a little bit of review. So you can pause the video if you need to. In looking at a sequence, I want you to see something here. For example, if we look at the common difference, or the first difference, what is my first difference here? Let me write first difference. Well, I can see it's going to be a 3. I can see it's going to be 3. I can see it's going to be 3. All right, we know it's a 3. Because it's a 3, that means we know, because we received a constant on the first difference, that means it's a what? I can't hear you. What is it? If you said a linear, you are correct. So it's going to be a linear sequence because we got a common difference after the first difference. Okay, now, when we get a linear sequence, much like what we just saw there in that example, what happens is it has a special name. That sequence is called an arithmetic sequence. So an arithmetic sequence is this. It's a sequence in which each term after the first term is found by adding a constant to the previous term. So when we find a common first difference, that is a linear sequence, which we will also call an arithmetic sequence. All right, now, just to review a little bit more. We have a term. Now remember what a term was, just to review here. Each number in the sequence. Now what does that mean? Well, that simply means that if I were to take, let's see here, let's say I were to create a little chart. The 0 would be term 1, 3 would be term 2, 6 would be term 3, 4, 5, and so on. Okay? All right, so those are terms. All right, go ahead and pause the video if you need to catch up on these to get these in your notes. Okay, the next thing we're going to look at is called a common difference. Okay? Now, a common difference. Remember when we got the first difference and it was 3 on the previous one that we just did? Well, it just so happens that a common difference, that 3, we're going to denote that as D. So it is the number D added to find the next term in an arithmetic sequence. Okay, so just to give you a quick example here, if I were to give, okay, so let's see, we had what? We had 0, 3, 6, so on and so forth. Okay, my common difference right there was a 3 because it went 3, 6, and so on. So my common difference, or my D value, was a 3. Okay, now let's review just a little bit more. Recursive rule. Remember what your recursive rule or your recursive formula was. It was like the directions. Okay, so it is a rule that is used to determine the next term of a sequence using one or more of the preceding terms. Which means, okay, remember for a recursive formula, I gave you a sub 1. And then I gave you a sub n, and this was some sort of rule. So usually it was, or should I say it was, a sub n minus 1. And remember, a sub n minus 1 means what? If you said previous term, you're right. And then we're going to do something to that previous term. Okay, so just to give you an example, if a sub 1 is a 0, now I'm going to use the example I had up above. The recursive rule to the sequence we've been playing with here is going to be the previous term, a sub n minus 1, plus 3. In other words, what did I do? I added that common difference to it. Now, that leaves us with an explicit rule, or an explicit formula. What is an explicit formula? An explicit formula is a formula that allows direct computation on any term for a sequence. Okay, so if I'm going to take a look at an explicit formula for the sequence 0, 3, 6, and so on, I first need to realize, okay, so first of all, let's draw a little something here. And I'm going to pick blue as a color here, and I'm going to do this. So this is our first, second, third, and so on terms of the sequence. Okay, so what we're going to do is I need to, first of all, identify what's my first term. So for my explicit rule, it is going to be a sub n is equal to, I start with the first term, and I'm going to add to it my d value, my common difference, which is going to be a 3, and then I'm going to times that by, and now is when we have to times it and kind of play with it, okay? So it's going to be n, or n minus 1, or something like that. All right, so let's just see what's going to happen. I'm going to put n minus 1. Now let's just take these, plug them in, see how it works. So let's just pick one, like the third term. If I take the third term, and if I want to find a sub 3, I plug the third term right in here. 3 minus 1 is 2. 2 times 3 is 6. 6 plus 0 is 6. So it works. So here is both the recursive and the explicit formula for the sequence that I've done right here. Okay, now before we get into these examples that I have, let's talk about the formal definition of the nth term of arithmetic sequence. Now, the formal definition says, the nth term, a sub n, is an arithmetic sequence with the first term, a sub 1. Okay, so let's think of it. My first term I can denote as a sub 1. Okay, the common difference is going to be d and is given by the formula. Okay, so the common difference is d. That is the difference between each term in the sequence. My first term is a sub 1. Okay, so let's take a look at what this formula is going to look like. The formula is going to look like a sub n, and a sub n means, if you want to know, like the 18th term, it would be like a sub 18 equals a sub 1 plus n minus 1. Now what is n? N is the nth term of an arithmetic sequence. So if I want to know the 18th term, n is 18 minus 1 times the common difference. So let's take a look at a real quick example kind of showing what this means using the example we did before. If I know the first, second, third term and so on, 0, 3, 6, dot, 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 I want to know what the 18th term is. All I will do is take that and I'm going to plug that 18 here. So that tells me that a sub 18 is going to be equal to the first term. What was the first term? Well, it was 0 plus 18 minus 1. And what was the common difference between each of these? Well, we found it to be 3. So you times that by 3. Alright, so that gives you a little idea. Now, when you simplify that, it will give you what the 18th term is. Okay, so that kind of explains the parts of this formula. Now, let's go see if we can learn how to do some problems that we're going to see in our problem set tonight. Let me start by writing the formula up here to the top. We had a sub n is equal to a sub 1 plus n minus 1 times my common difference. Okay, so in looking at this question here, it says over here, it says find a sub 14 for if my first term is a 4 and my common difference is a 3. Alright, so let's go ahead and just play with that a little bit here. So my 14th term. I want to find my 14th term. So I'm going to say a sub 14 is going to be equal to my first term, which is 4, plus, and then I'm going to have n minus 1. Well, remember my n is what? Well, my n value here is 14 because I want to find the 14th term. So I'm finding the 14th term. So it's going to be 14 minus 1 times my common difference, which is 6. Now we just use order of operations and simplify that. So what do we do first? Well, let's see. A sub 14 is going to be equal to, order of operations says I do parentheses first, so it's going to be 4 plus 14 minus 1 gives me 13 times a 6. Well, 13 times 6 is 78. And we're going to add 4 to that. So my simplification of that is going to be 82. So that tells me that the 14th term is 82. All right. Well, I'm going to stop right there, and we're going to play with 2 and 3 in class. So let's leave those blank for right now, and let's move on to some more. In this next problem, it asks us to write the recursive and the explicit rule and then find the term. Okay, so here we have the sequence here. So let's write the recursive rule for that first. To write the recursive rule, remember we need the first term, so I need to say a sub 1 is, what is a sub 1? Well, it's right there. Okay, so I'm going to put a 1. And then I need to say that a sub n is equal to, now remember when you're writing a recursive rule, you're going to say a sub n minus 1, and then you have to do something to that previous term. Remember the a sub n minus 1 means previous term. Alright, so how did I get from 0 to negative 3? Well, we subtracted 3. So it's just minus 3. So there is the recursive rule, or my recursive formula. Now let's go ahead and find the explicit formula for this. To find the explicit formula, I have a sub n is equal to, now we look here, to find the explicit rule, let's go back to the formula that we just learned. So remember you have a sub n is equal to your first term, which is a sub 1, plus, and then you have n minus 1 times the common difference. Alright, so we're going to use that. So I have a sub n is equal to my first term, which is 0, right there. So we put in a 0. Then it's going to be plus. Now, from here I'm going to put n minus 1. And what was my common difference between each of these? Well, negative 3, negative 3, negative 3. So I'm going to times that by negative 3. Okay, so there is my explicit rule. Now, we can go ahead and simplify that a little bit. And if we simplify it, we could say it'd be a sub n is equal to, I'm going to put that negative 3 in the front because, you know, it's multiplication. And community property of multiplication says that negative 3 times the quantity is the same as the quantity times negative 3. And there is my explicit rule cleaned up. Alright, now next it asks me to find the indicated term. So I want to know what is the a sub 10th term. So the a sub 10th term is simply going to be my first term plus, now remember right here, this is my n value right there. So because it's my n value, I'm going to put that 10 right here. So it's going to be 10 minus 1 times my common difference, which is negative 3. And then we're just going to simplify it. So a sub 10, simplifying this, it's going to be 0 plus, I have 9 times negative 3. 9 times negative 3 is negative 27. 0 plus negative 27 is simply going to be negative 27. So that means my 10th term of that sequence is going to be negative 27. All right, now we're going to stop right there. We're going to play with number 5 and 6 later on. This is going to be our last topic for today. Now, in this one here, we need to define what an arithmetic mean is. So, someplace in your notes, I want you're going to see on the second page, about halfway down, you're going to see where it says arithmetic mean. Now, arithmetic mean, so squeeze this definition in there, it is the terms between any two non-consecutive terms of an arithmetic sequence. Okay, again, an arithmetic mean is the terms between any two non-consecutive terms of an arithmetic sequence. In other words, I have a 5, I have a -3. They are not consecutive. What's the word consecutive mean? Anybody know? Well, let me help you out with that. Consecutive means one right after another. 5 is not after -3 because there are 3 wholes in there. So they're non-consecutive. So an arithmetic means are the terms between these. So we need to find the arithmetic mean. So when I put my little marker here, these are called arithmetic means. So I need to find those arithmetic means. Okay, so let's use what we know already. And using the arithmetic mean, write the recursive and explicit rules, and then those rules to generate the missing terms. Okay, so let's go ahead and do this. Okay, so first of all, I have, what do I have? Well, let's see. I know the first term. The first term is 5. And I know the fifth term. What is the fifth term? Well, what is it? -3, it looks like. All right, now, let's remember what our formula was. Our formula was a sub n is equal to a sub 1, our first term, plus n minus 1 times my common difference. All right, so let's put that in place there. So, first of all, I'm going to look at it this way. We're going to say that a sub 5 is equal to a sub 1 plus, and then it's going to be 5 minus 1. Why did I use a 5? Well, guys, this is why. It's the fifth term. That's why I used a sub 5. Times our common difference, and I don't know what the common difference is. Now, folks, let me ask you, do we know the first term right there? And do I know the fifth term right there? Well, yes, I do. It's 5 and -3. All right, so let's go ahead and put those in place right there. Okay, so we are going to plug a -3 in for the a sub 5. We're going to plug in a 5 in for the a sub 1 plus 5 minus 1 times d. Now let's solve for d. Now I have a linear equation. Look first of all at the right side of the equal sign. Can we simplify that? Well, order of operation tells us we need to do what first? If you said parentheses, you are right. So I'm going to just bring down this -3, and that's going to give me 5 plus 4 times d. Oops. Let me undo that a bit. 4 times d. Okay. Now I'm going to subtract 5 to both sides, and in doing so, that gives me -8 is equal to 4d. Now, how do I get the d by itself? If you said divide by 4, you are correct. So I'm going to divide by 4 on both sides, and that gives me d is equal to a -2. So what is my common difference? It's -2. So let's come up with a formula here. So, first of all, my recursive rule, well, I know that a sub 1 equals a 5. And what is my a sub n? Well, it's going to be the previous term, a sub n minus 1. And what am I going to do to it? I'm going to add or subtract. Well, you could add a -2, or I could just say -2. So there's my recursive rule. Now let's find the explicit one. To find the explicit rule, it's going to be a sub n is equal to, let's see, I have my first term, which is 5. And then it's going to be plus we have n minus 1 times my common difference, which is negative 2. Now, if you'd like, you could clean this up a little bit, or you can leave it just like that. I'm thinking to myself, what do I want to do? Well, I'm going to go ahead and clean it up a little bit. So that's going to give us a 5 plus, I distribute the negative 2 inside, which gives me negative 2n plus 2. I'm going to add like terms. My like terms are these two numbers right there, so that gives me negative 2n, and 5 plus 2 is 7. So there is my explicit rule right there. Now, take it, plug stuff in, see if it works. Now, at this point, guys, let's go ahead and let's find what the rest of these terms are. Well, remember, if I just went 2 at a time, or subtracted 2, 5 minus 2 is, well, if you said, 3, that is correct. Then minus 2 again, which gives me a 1. Then minus 2 again is negative 1. And then lastly, it goes to negative 3 if I subtract 2 again. Now, I could also generate each of these right here. I can generate each of those by plugging 2 or 3 or 4 in for n to find the a sub 2, a sub 3, or a sub 4 terms. Okay, folks, I'm going to stop right there for this lesson. And in class, we're going to play a little bit more with 8 and 9. For our problem set next class period, our goal is to, well, what do you want to do? Hey, how about we finish this, and I'll put a C there because it's a Cornell note guide. Okay, so our homework, well, actually our classwork next class period is we are going to finish this note guide. So, well, folks, I'm going to call it a wrap for today, so I will see you in class.